So today we're going to be looking at counting functions, and counting is nowhere near as easy as you might think, because it's very easy to double count or miss certain possibilities. What's it all about, this counting functions? Well, just to recap, a function is defined as every element in the input or the domain here has to match with exactly one element in the output codomain here. Okay, so let's imagine that we have m elements in here and we have n elements in here. Then, given no constraints whatsoever on how the function can be produced, we would be able to count n to the power of m possible functions. So just to give an example, let's imagine that we have this as our domain 1, 2 and 3, and we have as our codomain A, B, C and D. Then there are, well, basically there would be 4 to the power of 3, which equals 64 possible functions. Now, just as a matter of interest, one of those functions would be that 1 could map to A, 2 could map to A, and 3 could map to A. There's absolutely nothing wrong with that. There's no constraints because each of these is mapping to 1. It doesn't matter if it's the same one, a different one. It doesn't matter. We're not dealing with injective and surjective functions or anything. All we're dealing with is a function, so it must match to 1. So what we're going to do is we're going to do 4 different questions, and they are a little bit tricky. So I think the best way to deal with these is just to practice the different sorts. Okay, so let's go on to question 1. Here's question 1, okay, from its JEE Main July 22 shift 1. Anybody who'd like to have a go at that, just pause the video. Okay, now the main problem with these actually is understanding what the question is actually saying. So what it's asking for is how many is the total number of functions. Here is the domain 1, 2, 3 and 4, and here is the codomain 1, 2, 3, 4, 5 and 6, and they're giving us this constraint that f1 add f2 minus f3 f1 add f2 is equal to f3. Okay, so what we need to do is we need to look and see how many functions satisfy this constraint here, and the best thing to do is always look at the biggest number. Well, the biggest number, clearly, if this is f1 and this is f2, well, the biggest number is going to be f of 3. Now, given that we only have a constraint on f1, f2 and f3, that means that the number 4 can map to anything. So we know always that f of 4 can be anything from 1, 2, 3, 4, 5 and 6. So we'll use that later on. Okay, so first of all, let's have a look at f3. Well, f3 cannot map to 1, so it's f1 add f2 equals f3. That's the constraint that we're dealing with. Well, f of 3 clearly cannot map to 1, because if f3 maps to 1, well, what are f1 and f2 going to map to? Because the minimum that they can map to is 1. Well, 1 plus 1 is 2, so f3 cannot possibly be equal to 1. So let's have a look at what happens if f3 equals 2. Well, if f3 is 2, well, clearly that means f1 must be 1 and f2 must be 1. So there is only one possibility. If 3 maps to 2, there can only be one possibility, which is 1 must map to 1, 2 must map to 1, and of course remember 4 can map to anything, so if f is 3, that means we have 1 times 6 possible functions. What about if f maps to maps 3 to 3? Okay, well, if it maps 3 to 3, well, we have 2 possibilities. 1 could map to 1 and 2 could map to 2, well, that would add up, or 1 could map to 2 and 2 could map to 1. That would work with this constraint here. So clearly here there are 2 possibilities, times by, remember, 4 can be anything, so that would be 2 times 6. Okay, so let's have a look at what happens if f of 3 maps to 4. Okay, well, f of 1 could be 1 and f of 2 could be 3, that would work, or f of 1 could map to 2, f of 2 would be 2, or f of 1 is 3 and f of 2 is 1. All 3 of those work. Okay, so there's 3 there times by, of course, 4 can float completely freely to any of the 6. That would be 3 times 6. Okay, now what about f of 3 equals 5? F of 3 equals 5. Well then, if f of 3 equals 5, then we could clearly have f of 1 being 1 and f of 2 being 4, or f of 1 being 2 and f of 2 being 3, or f of 1 being 3 and f of 2 being 2, or f of 1 being 4 and f of 2 being 1. So clearly there are 4 times 6 there. And finally, if we allow 3 to map to 6, well then f of 1 could be 1, 2, 3, 4, or 5, and f of 2 could be 5, 4, 3, 2, and 1. So there's 5 possibilities there, so that would be 5 times 6. So the total number of possible functions whereby this constraint here, f1 add f2 equals f3 works, is 1 times 6, add 2 times 6, add 3 times 6, add 4 times 6, add 5 times 6, which is 5 and 4 is basically 15 times 6, 5 and 4, yep, which equals 90. So the correct answer is B, 90. Okay, so that's that question done. What about the next question? Pause the video if you desire to have a go at that question. Okay, so the problem with a lot of these questions is actually trying to understand what on earth it's saying. So let's have a look. So we've got what they're asking for is the number of functions from the set A to the set B under this constraint here. Okay, so the set A, let's have a look at what that is first. Well, A is the set of x contained in n such that x squared minus 10x add 9 is less than or equal to 0. Okay, well, x squared minus 10x add 9, we can write that as x minus 9, x minus 1. And for that to be less than or equal to 0, clearly x has to be between 1 and 9. So basically A, we can rewrite A as being the set 1, 2, 3, 4, 5, 6, 7, 8 and 9. That's the set A. And let's have a look at the set B. Well, the set B is the set of n squared, so that's 1, 4, 9, 16, 25, 36, 49, etc, etc, etc. So now what's it asking us? So basically what it is saying is f of x must be less than or equal to x plus 3 squared add 1 for all of the x in A. Okay, well, let's have a look then. So basically, let's have a look at the number 1. So this is number 1. So f of 1 must be less than or equal to, and what I'm going to do here is stick 1 in here, 1 minus, my apologies, 1 minus 3 squared add 1. All I've done is I've put 1 into here because that's the constraint, which equals 5. So f of 1 must be, so f of 1 can be either 1 or 4. If it maps to 1 or 4, that is less than or equal to 5. Okay, now what about A equals 2? Well, f of 2 has got to be less than or equal to 2 minus 3 squared add 1, which equals 2. So therefore, 2 must get mapped to 1 only. What about 3? F of 3 must be less than or equal to 3 minus 3 squared add 1, which equals 1. So f of 3 must be less than or equal to 1. So clearly 3 can also only map to 1. So that can map to 2, 1 or 4. That can map to 1 only. That can map to 1 only. That's the number of mappings that there can be, and this is the actual number here. What about 4? Well, f of 4 must be less than or equal to 4 minus 3 squared add 1, which is 2. So therefore 4 can only map to, again, to 1. 4 can map to 1. Okay, so that can only map to 1. What about 5? Let's move up here. Well, f of 5 must be less than or equal to 5 minus 3 squared add 1, which equals 5. So therefore f of 5 could be 1 or 4, which is 2 different possibilities. Then 6, well, f of 6 must be less than or equal to 6 minus 3 squared add 1, which is 10, so therefore 6 could get mapped to 1 or 4 or 9, which is 3 possibilities. Now in actual fact we don't need to fill in for 7, 8 and 9. It is clear that 7, 8 and 9, f of 7 is going to map to 1 or 4 or 9 or 16, and f of 8 is going to be 1 or 4 or 9 or 16 or 25, and f of 9 is going to be 1 or 4 or 9 or 16 or 25 or 36. And so basically the total number of possible functions that there are is going to be the multiplying of all of these, which is 6 factorial times 2. So it's 6 factorial times 2, times 2. Well, 6 factorial is 720 times 2 equals 1,440 possible functions such that that constraint works. Okay, that's number 2. You can see they're a bit fiddly. You just have to try and understand what it is the question is asking. Let's have a look at question number 3. Okay, so question 3, if you want to pause the video now, please do so. Okay, so this one we have here is our domain 1, 2, 3 and 4, and here is the codomain, the set of A contained in the integers such that the modulus of A is less than or equal to 8. Well, clearly that will be the set -8, -7, -6, -5, 0, 7, 8. That's that set there. Okay, so it's saying that f of n, add 1 over n, f of n plus 1 must equal 1 for all n in 1, 2 and 3. Okay, so basically again what we want to do is we want to look at the number which is the highest and the most constrained. So obviously what we want to do is let's just put in, say for example, 1 in here and see what's going on. That'd be f of 1, add 1 over 1, f of 2 must equal 1, and then let's just put in 2 just so we can get a good idea of what on earth they're asking. F of 3 must equal 1, and f of 3 add a third f of 4 must equal 1. Okay, right, so basically from this one we know that f of 4 must be divisible by 3 or equal to 0, and from this one here we know that f of 3 must be even or equal to 0. So what we want to do is we want to look at f of 4. Okay, so let's look at f of 4. Well, f of 4, if it's got to be divisible by 3, then f of 4, given that it can only be mapped to one of these, it must be either 6, 3, 0, minus 3, or minus 6. Now, if f of 4 maps to 6, then from here, f of 3 must be, well, a third, 6 divided by 3 is 2, and so f of 3 must therefore map to -1. But f of 3 cannot map to -1 because f of 3 must be even, and so therefore there are 0 possibilities when f of 4 is 6. What about when f of 4 is 3? Well, if f of 4 is 3, then a third of f of 4 is 1, therefore f of 3 must be 0, which is fine. F of 3 can be 0. If f of 3 is 0, that means that half f of 3 is 0, which means f of 2 must equal 1 in order to satisfy this. And if f of 2 equals 1, then f of 1 must be 0. But that is a possible solution, so we have found one possible function. Now, what about if f of 4 equals 0? Well, if f of 4 equals 0, then a third of 0 is 0. That means that f of 3 must be 1 from this third equation here. Well, that can't be possible because f of 3 is even, so we can strike that one out. What about if f of 4 is minus 3? Well, a third of minus 3 is minus 1, which would mean that f of 3 must be 2. Well, that's possible because that is an even number. If f of 3 is 2, half of f of 3 is 1, that means f of 2 must be 0. And if f of 2 is 0, that means f of 1 must be 1. And that works. That's another possible. So we have another possible. And finally, all we need to do now is check if f of 4 is minus 6. Well, if f of 4 is minus 6, then a third of minus 6 is minus 2, which would mean that f of 3 would have to be 3. And f of 3 can't be 3 because f of 3 must be even. So that can't work as well. So therefore, there are two possible functions that satisfy this constraint. And so therefore, the answer is D. Okay, so let's go on to the last one. You can see they're all different, and you just have to really try and examine the question. So anyone who wants to do this, try and pause the video. Okay, so we got A is 1, 2, 3, 4, 5, that's the domain, and B is 1, 2, 3, 4, 5, and 6. Okay, then the number of functions A to B satisfying f1 add f2 equals f4 minus 1 is equal to what? Okay, so we have to find the number of functions. The first thing we should notice is that 3 and 5 can both map to anything because they're not included in our constraint. So therefore we know that 3 can map to 6 different things and 5 can map to 6 different things. So we know that between them, that's going to be 6 times 6 possibles. Now we only have to look at f of 4. So let's have a look at f of 4, and then let's just have a look at f of 4 minus 1, and then let's have a look at f of 1 and f of 2 like this. Okay, now let's just put f of 1, f of 4, well, let's have a look, 1, 2, 3, 4, 5, and 6. Okay, now if f of 4 equals 1, then f of 4 minus 1, then if f of 4 equals 1, f of 4 minus 1 is 0. Well, okay, well, clearly f1 add f2 can't be equal to 0 because all of the numbers are positive in the codomain, so that we can write off. What about if f of 4 is 2? Well, for the same logic, that means f of 4 minus 1 is 1. Well, f of 1 add f of 2 can't possibly equal 1, and so we can knock that one out. If f of 4 is 3, then f of 4 minus 1 is 2. Well, basically, that means that f of 1 must map 1 and f of 2 must be 1. That's the only possible that can satisfy this constraint, which is 1 possible. What about f of 4 at 3? Well, basically, f of 1 could be 1 and f of 2 could be 2, or f of 2 could be 2 and f of 2 could be 1. So that's 2 possible. And then 5, well, we can, so basically if f of 4 is 5, f of 4 minus 1 is 4. So f of 1 and f of 2 could be 1, 2, and 3, or 3, 2, and 1, which is 3 possibles. And then finally for 6, clearly it's going to be 1, 2, 3, 4, or 4, 3, 2, 1, which is another 4 possibles. So basically adding these up, 4 add 3 add 7 add 1 is 10 times by 36, because 3 and 5 can map to anything, so it'll be 10 times 36, which equals 360 possible functions which satisfy this constraint. Okay, now all of these 4 questions were just normal functions. There was no injective functions or surjective functions or bijective functions. A lot of these questions also ask on counting functions for those types, injective, surjective and bijective, and the next few videos we're going to do are going to be on that. I hope you found this useful. If you have, please like the video and subscribe to the Gresti Academy YouTube channel. Thank you.